I'm going to go over the 4.4 quick check answers. Okay, first off, we have a nice chart here, and this is about naming those acids. So part of this is knowing your ions to be able to do this. But we start off with NO3 minus. Okay, I'm going to jump over here to the formula of the acid. Since this is a -1, that means we're going to need one H, because you know acids always start with H. So the formula is going to be HNO3. Now the name of that is nitrate. And we care about that because it ends in 8. That means the answer, the acid, is going to be ic acid. So remember here, if it's 8, then it's going to turn into ic acid. If it ends in ide, then it's going to be hydroic acid. Okay, those are the two big rules. So in nitrate, it's going to be nitric acid. Okay, chloride, we're supposed to know chloride is Cl minus, and since it's a -1, then we know we need to put one H with it, so HCl. And since it ends in ide, okay, it's going to be hydrochloric acid. Okay, so it's hydroic acid. This guy is ic acid, this is a hydroic acid. Okay, H2S, we have to work backwards now. Okay, we know that there's two H's. That means that S must be 2 minus. And if we know our ions, we know that that is called sulfide. So sulfide is hydroic acid. But because it's got a sulfur in it, okay, then we're going to add a UR just to make that sound good. So sulfurs, we're going to put in a UR. And if we have a phosphorus, we're going to put in an OR just to make it sound good. Okay, so this is going to be hydrosulfuric acid. Okay, so that's the little UR that we added. So if you just follow the rules, you might say hydrosulfuric acid, but it's hydrosulfuric. Okay, working from the name, since it says ic acid, then we know that this meant end in 8. Okay, and chrome, so it's chromate. And hopefully remember chromate is CrO4, 2 minus, and this is where knowing your ions is going to help you. Okay, and since it's 2 minus, it's going to have two H's, so H2CrO4, chromic acid. Now there's a bunch of formulas in here, and we're not going to ask you these formulas, but you are going to use them. So one little idea here is that the pH plus the pOH always adds up to 14. So if you know the pH, you can subtract from 14 to get the pOH, and vice versa. So that's a really nice little formula. And the same way, the H plus times the OH is always 1 times 10 to the negative 14. So we're seeing that when you have a compound, you know, when you have a molarity of H plus or OH minus, you can usually do it just by looking at it and decide, you know, because the exponents add up to negative 14. Officially, the pH is the negative log of the H plus concentration. Okay, you can just usually do that in your head by looking at the exponent, but that's what it is. And the same way, the pOH equals the negative log of the OH minus concentration. And going backwards, if you know the pH, you can calculate the H plus, because you just have to put it in as the exponent. And the same thing for OH minus is the 10 to the negative pOH. So these formulas here are really especially useful when you have to use a calculator, which we're not going to do on this test. Okay, you're not going to see this kind of problem at all. So this is kind of optional. Save it for college. Okay, you are going to do problems like this. So look at this table, and you say, okay, this is 1 times 10 to the minus 3, so we know this must be 1 times 10 to the minus, okay, the exponents have to add up to negative 14, so this must be minus 11 molar. Now if that is 10 to the minus 3, the pH must be 3, and if this is 10 to the minus 11, the pOH is 11, and we double check, do those add up to be 14? Yes, they do, so that's good. And we're going to look just at the pH and decide whether it's acidic, basic, or neutral. And any pH less than 7, that is an acid. So that's the first row. Okay, second row. This is 10 to the minus 6. So this must be 1 times 10 to the negative 8 molar. Okay, because negative 6 and negative 8 add up to negative 14. Or these two numbers multiply to give you 1 times 10 to the negative 14. If this is negative 8, the pH is 8. And right now, if we know a pH is 8, we say, okay, this is a basic solution. Anything greater than 7 is basic. And the pOH, we look at here, so we know the pOH is 6. And we double check, do these add up to 14? Yes, they do. Okay, that's good row. Okay, next one here, this is the pH of 11. Okay, well, if that's 11, that we know that the pOH must be 3 because these always add up to 14. Okay, and we can say 3.0. And if this is 11, then we know that this must be a base, anything greater than 7. So again, we only look at the pH to figure out acid, base, or neutral. If this is 11, then this is 1 times 10 to the negative 11. And since this is 3, this is 1 times 10 to the minus 3 molar. Okay, so that's that row. Now we go back here and say, okay, here's 1.0. Well, we know that this one and this one add up to 14, so this must be 13.0. Okay, if it's 13.0, that's absolutely positively basic. Anything greater than 7, that's a lot greater than 7. So this first number is 1 times 10 to the negative 13. And the second one is going to be 1 times 10 to the negative 1. And that's that row. Okay, the last one here, because this is neutral, then this is the only time where we know the pHs are 7. So pH and pOH are both 7, because that's why it's neutral. They're the same. And both of these are 1 times 10 to the negative 7th molar. And that's this entire quick check.